evening all. I welcome you all for the special lecture. We request the students to settle down fast as the program is about to begin.
So we request all the audience to stand up and show your reverence when the chief guest enters the auditorium.
Good evening all. I welcome you all for this special lecture organized as a part of our Founders Day celebration.
As we begin every event and occasion with a prayer song, I request everyone to rise up and pay reverence to Tamilthai Valthu.
நீராறும் கடலுடுத்த நிலமடந்த கெளிலொழுகும் சீராறும் வதனமென திகழ் பரத கண்டமிதில் தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Please take your seats, everyone. Thank you. I am honored to invite our esteemed principal, Dr. K. Kalvithanthai, Principal, National Engineering College, to share his welcoming words.
So, respected Chief Guest of the Day, Dr. V. Narayanan, Director, LPSC, ISRO, Vaniyamala, Kerala. Special guest, Mr. V. Sendil Kumar, ISRO, Satellite Center, Bangalore. Respected Chairman, Vice Chairman, Correspondent, Managing Committee members, Director of NAC, Principals of LAPC and KR College of Arts and Science, staff members, students, parents, and all stakeholders of KR Group of Institutions, ladies and gentlemen. Good evening to all. We all know our beloved Kalvithanthai K. Ramasamy established these institutions, National Engineering College, Ramasamy Polytechnic College, KR College of Arts and Science, with a strong vision of transforming the rural's life through quality education. All three institutions were equipped with state-of-art infrastructure, classroom, laboratory, research facilities, team of faculty members with dedication and commitment, and a teaching educational model. With this, we are capable of producing industry-ready and ready-to-employ graduates in the field of arts, science, and engineering. With this facility, towards achieving our vision of transforming the lives, our institutions so far produced 34,290 graduates and diploma holders. Every year, we are used to conduct 25th year alumni reunion. From this reunion, we came to know that most of our alumni were successfully settled in their professional life and personal life. They are working in different places all over the world in different positions in reputed organizations like CEO, Vice President, Division Head, and contributing the successes and the growth of the organization where they are working. So this data confirm the continuous achievement of our beloved chairman's vision of transforming the life of the rural people and their generations. Founders Day is extremely important for the group of institutions for two reasons. One, it is a day on which we celebrate our achievements, our many achievements, individual and collective. Second, it is an important occasion for all these three institutions to be together, to do things together, and to make a pledge to continue to work with the commitment and making the vision of our beloved founder chairman by providing quality education, by bringing continual improvement in educational process to meet out the growing needs of the international community. In this special occasion, on behalf of chairman, vice chairman, correspondent, and other managing committee members, director, principals of Ramasamy Polytechnic, KR College of Arts and Science, I welcome Dr. V. Narayanan, distinguished scientist, Apex grade, Director, LPSC, ISRO, Vaniyamala, Kerala, who is going to deliver lecture on Indian Space Program, past, present, and future. Next, I welcome our special guest, Mr. V. Sendil Kumar, Head Antenna and Passive Systems Division, Communication System Groups, ISRO Satellite Center, Bangalore. He is also our distinguished and notable alumnus of NAC ECE 1992 batch. Next, I welcome the trust lawyers, auditors, and management guests, press and media for the program. Next, I welcome HODs, deans, COEs, all faculty members and other non-teaching members of NAC, LAPC, and KR College of Arts and Science who are attending this program from their institutions. Next, I welcome all these students, alumni of NAC, LAPC, KRAC, and all are all participating in this program and watching the events through live stream. I welcome all the parents, well-wishers, and all other stakeholders who are all participating through live stream. Once again, I welcome you all for this program. Thank you.
Thank you, sir. Remembering the words of Maya Angelou, do the best you can until you know it's better. Then, when you know better, do better. Our founder, Kalvithanthai, Thiru Ramasamy, has led a foundation which has have been bettering lives of hundreds of students every year. Now I am glad to call Mr. V. Armugam, Head of Science and Humanities Department, Lakshmi Mall Polytechnic College, to share few words about the founder of KR Consortium.
கல்வி தந்தை என்றும் கேஆர் என்றும் எல்லோராலும் அன்பாக அழைக்கப்படுகின்ற இக்கல்லூரியின் நிறுவனர் திரு கே ராமசாமி அவர்களின் பிறந்தநாளான இன்று நிறுவனர் விழா உரையாற்ற வந்திருக்கின்ற திருவனந்தபுரம் ISRO லிக்விட் ப்ரொபல்ஷன் சென்டருடைய இயக்குனர் முன்னோடி விஞ்ஞானி டாக்டர் நாராயணன் அவர்களே, பெங்களூர் ISRO கம்யூனிகேஷன் சிஸ்டம் உடைய தலைமை பொறுப்பு இருக்கின்ற நம்முடைய முன்னாள் மாணவர் திருமதி செந்தில்குமார் அவர்களே, கல்வி குழுமங்களின் துணைத் தலைவர், தாளாளர், இயக்குனர், முதல்வர் பெருமக்கள், துறை தலைவர்கள், பேராசிரியர், மாணவர்கள் மற்றும் விருதில் அடங்கிய அவையினை வணங்கி ஒரு சில வார்த்தைகள் நம்முடைய கல்வி தந்தையை பற்றி பேசலாம் நினைக்கின்றேன். செப்டம்பர் 17 என்பது நம்முடைய கல்வி நிறுவனங்களுடைய வரலாற்றில் பொன் எழுத்துக்களால் பொறிக்கப்பட வேண்டிய நாளாகும். ஆம், அந்த தினத்தில்தான் நம்முடைய நிறுவனர் KR அவர்கள் உலகில் தோன்றினார்கள். தென் தமிழக மக்கள் வாழ்க்கையிலே ஒளியேற்றிய கல்வி தந்த வள்ளல் திரு KR அவர்களுடைய விழாவில் பேசுவதை நான் பெருமையாக நினைக்கின்றேன். இந்த வாய்ப்பளித்த எனக்கு நன்றியை தெரிவித்துக் கொள்கின்றேன். ஒரு 40 ஆண்டு காலம் அவரை நான் அறிந்தவனாக இருக்கின்றேன். அவருடைய சிறப்புகளை எடுத்து சொல்வது என்று சொன்னால் பல மணி நேரம் ஆகலாம். இருந்தால் அவற்றில் ஒரு சில சிறப்புகளை உங்கள் முன்னால் எடுத்துரைக்க ஆசைப்படுகின்றேன். எத்தனையோ மனிதர்கள் வெற்றி பெற்றிருக்கிறார்கள், பெரிய தொழில் அதிபராக சிறந்து வந்திருக்கின்றார்கள், வெற்றி நடை போட்டு இருக்கிறார்கள். எல்லோருடைய வாழ்க்கையிலையும் உழைப்பு உண்டு. வெற்றி பெற்ற அனைவரும் உழைத்திருப்பார்கள். விடா முயற்சி இருந்திருக்கும், அவருடைய மன உறுதி இருந்திருக்கும், அதில் சந்தேகம் இல்லை. எல்லோரை விடவும் வளர்ந்த தொழில் அதிபர்களுக்கெல்லாம் தொழில் அதிபர்களாக சிறந்து விளங்கிய நம்முடைய KR அவர்கள் மற்றவர்களது சில விஷயங்கள் வேறுபடுகிறார்கள். மற்றவர்கள் வெற்றியை பெற்றிருப்பார்கள், அதோடு நின்று இருப்பார்கள். நம்முடைய நிறுவனர் KR அவர்கள் அப்படி அல்ல. பல துணிச்சலான முயற்சிகளை மேற்கொண்டு இந்நாட்டில் மட்டுமல்ல வெளிநாட்டிலேயும் அவர்கள் சில பணிகளை சிக்கலான பணிகளை மேற்கொண்டு அதனை திறம்பட செய்து வெற்றி பெற்று பெரும் புகழும் பெரும் செல்வத்தை ஈட்டியவர்கள். சாதாரண மனிதர் செய்யக்கூடிய காரியம் அல்ல. மிகுந்த மதி நுட்பமும் மன துணிச்சலும் உள்ள மனிதர்கள் மட்டுமே அந்த காரியத்தை செய்ய முடியும். அதை செய்தவர்கள் நம்முடைய KR அவர்கள். இதனுடைய வாழ்வின் முதல் கட்ட வாழ்க்கை என்று எடுத்துக்கொள்ளலாம். கிட்டத்தட்ட 50 வயதிற்குள்ளாகவே இதனெல்லாம் செய்து முடித்து விட்டார்கள். அதற்கு பின்னர் அவர் செய்த காரியங்கள் தான் அவருடைய புகழுக்கான காரணமாக இருக்கின்றன. அப்போது 50 வயது நெருங்கும் பொழுதுதான் கல்விக்கான நம்ம பணியை செய்யணும்னு நினைத்தார்கள். இந்த கல்வி நிறுவனத்தை நிறுவினார்கள். கல்வி பணி மட்டுமல்ல, ஆன்மீக பணி அதையும் செய்து எல்லோராலும் போற்றப்பட்டு பெரும் புகழுக்கு ஆளான உடை வள்ளல் என்ற பெயரோடு மிக சிறப்பான ஒரு வாழ்வை பெற்றார்கள். பல சிறப்புகள் இருந்தாலும் அவற்றையெல்லாம் சொல்லிவிட முடியாது. முக்கியமாக அவருடைய எளிமையான தோற்றம். பெரியவர் சொல்வாங்க, எல்லா பெரியவர்களுமே சிறந்த மனிதர் எல்லோருமே அவருடைய ஒரு ஒற்றுமை உண்டு. மகாத்மா காந்தியாக இருக்கட்டும், சுவாமி விவேகானந்தராக இருக்கட்டும், அப்துல் கலாம் ஆகட்டும், நெல்சன் மண்டேலா ஆகட்டும், அன்னை தெரசா ஆகட்டும், எல்லோரிடம் ஒரு ஒப்புமை என்னவென்று சொன்னால் அவருடைய எளிமையான வாழ்க்கை. அப்படிப்பட்ட எளிமையான வாழ்க்கை தான் அவர்களை மிகச்சிறந்த மனிதர்களாக மனிதர்களாக உலகில் நிலைநிறுத்தியது. அப்படிப்பட்ட எளிமையான தோற்றமும் எளிமையான வாழ்க்கையும் கொண்டவர் நம்முடைய கல்வி நிறுவனம் அவர்கள். அவர்கள் மற்றவர்களுக்கு இல்லாத, மற்ற தொழில் அதிபர்களுக்கு இல்லாத ஒரு சிறப்பு அவர்களுக்கு அந்த எளிமையான வாழ்க்கை முறை என்று சொன்னால் மிகையாகாது. எளிமை என்பது ஒரு மனிதனின் அடையாளம். அந்த அடையாளத்தை அவர் பெற்றிருந்தார். அதோடு அவருடைய நேரடியான தொடர்பு பெற்ற சில விஷயங்களை உங்கள் முன்னால் சொல்ல ஆசைப்படுகின்றேன். நான் அவரை முதன்முறையாக சந்தித்தது 1984ஆம் ஆண்டு. இந்த நிறுவனம் ஆரம்பிக்கப்பட இருந்த நேரத்தில் ஆசிரியர் பணிக்காக அவர்களை சந்தித்தேன். அவருடைய அலுவலகத்தில் இளையரசன் ரோட்டில் இருக்கின்ற அந்த அலுவலகத்தில் சென்று சந்தித்தேன். சந்தித்தவுடன் அவர்கள் நல்ல முறையில் புன்முறையோடு வரவேற்றார்கள். ஆனால் ஒரு செய்தியை சொன்னார்கள், தம்பி நீங்கள் பெரிய இடத்து பிள்ளை ஆயிற்று, இந்த ஆசிரியர் பணியெல்லாம் உங்களுக்கு ஒத்து வருமா என்று கேட்டார்கள். நான் சொன்னேன், பெரிய இடமெல்லாம் ஒன்றும் இல்லை ஐயா, ஆசிரியர் பணியை மேற்கொண்டால் அதற்கு நடைமுறையை கண்டிப்பாக பின்பற்றுவேன், எந்த விதமான குறை கூறுவதற்கு வழி இல்லாதவன் பணியை நிறைவேற்றுவேன் என்று சொன்னேன். லேசாக சிரித்து கொண்டார். அந்த சிரிப்புக்கான காரணம் எனக்கு இதுவரை வழங்கவில்லை. ஒருவேளை எல்லாரும் இப்படி தான் சொல்லுவார்னு நினைத்திருக்கலாம், அல்லது பரவாயில்லை நம்ம கேட்ட கேள்விக்கு சரியாக பதில் சொல்லியிருக்க நினைத்திருக்கலாம். தெரியல, சிரித்த சிரிப்புக்கான பொருள் எனக்கு இதுவரை வழங்கவில்லை. ஏதோ ஒரு முடிவு எடுத்திருக்கிறார், எனக்கு அது மகிழ்ச்சி. இங்கே வேலை செய்ய வாய்ப்பு அளித்தார். அதே போல் இன்னொரு சமயம் அவருடைய இன்னொரு சிறந்த குணம் என்று சொன்னால், தன் நிறுவனத்தில் பணியாற்றுகின்ற பணியாளருடைய வீட்டு நிகழ்வுகளுக்கு தவறாமல் சென்று வருவார். நான் என்னுடைய குழந்தைகளுக்கு கிட்டத்தட்ட 35 ஆண்டுகளுக்கு முன்னால் திருச்செந்தூர் முருகன் கோயிலை வைத்து முடி காணிக்கை செய்து காதனை அணிவிக்கிற விழாவிற்கு அவர்களை அழைத்தேன். தலைமை பொறுப்பேற்க என்று சொன்னேன். முதலில் சொன்னார்கள், இதற்கான தலைமை எதற்கு என்று கேட்டார்கள். பிறகு இல்லை, பரவாயில்லை, குழந்தைகள் விழா, அதுவும் கோயில் நடைபெறுகிறது என்று சொன்னார்கள். கண்டிப்பாக வருவேன் என்று சொன்னார்கள். வந்தார்கள். மன மகிழ்வோடு குழந்தைகளை வாழ்த்தினார்கள். இது அவருடைய மிகச்சிறந்த பண்பில் ஒன்றாகும். ஸோ அந்த பண்பின் தொடர்ச்சியாக இன்றும் அவருடைய வழித்தோன்றல்கள் இன்றும் இங்கே இருக்கிற பணியாளர்கள் வீட்டில் நடைபெறுகிற நிகழ்வுகளில் யாராவது ஒருவர், தாளாளர் அல்லது துணைத் தலைவர் அல்லது செயலர் தவறாமல் கலந்து கொள்வதை நான் பார்க்கிறேன். இந்த மாதிரி பண்பாடு எல்லா மனிதர்களுக்கும் இருக்காது, அவர்களுக்கு இருந்தது. இன்னொரு ஒரு சிறிய உதாரணம், என்னுடைய மைதின திருமணம் ஒன்று நடந்தது. அதிலே அவர்கள் கலந்து கொண்டார்கள். திருமணம் நடந்த இடம் பாளையங்கோட்டை அருகில் உள்ள ஒரு கிராமத்தில். இந்த மாதிரி மண்டபம் கிடையாது. வீட்டில் முன்னால் பந்தல் அமைப்பு திருமணம் நடைபெற்றது. உணவுக்கூடம் என்று பெரிதாக சொல்லக்கூடிய எதுவுமே இல்லை. ஒரு சிறிய உணவுக்கூடம். நெருக்கடியான நிலைமை. அவர்களை அங்கே அமர்ந்து உண்ண வேண்டாம், வாருங்கள், தனியாக உங்களுக்கு நாங்கள் உணவு ஏற்பாடு செய்யணும்னு சொன்னோம். முதல்ல மறுத்து விட்டார்கள், வேண்டாம், நானும் கூட்டத்தோடு அமர்ந்து சாப்பிடுகிறேன் என்று சொன்னார்கள். பின்னர் வற்புறுத்தி அழைத்த பிறகு வந்தார்கள். தனியாக அமர வைத்து உணவு பரிமாறினோம். இருந்தாலும் சாப்பிட்டு முடிக்கிற வரை மற்ற மனிதர்களையும் நீங்கள் கவனிங்கள், மற்ற விருந்தினரையும் பாருங்கள் என்று சொல்லிக்கொண்டே இருந்தார்கள். இதுதான் அவருடைய வேறுபாடு. மற்ற பெரிய ஆளாக இருந்தால் என்னை கவனிக்கவில்லையே, எனக்கு மரியாதை தரலையே அப்படின்னு குறை சொல்லியிருப்பாங்க. ஆனால் நம்முடைய KR வந்து வேறுபட்டவர்கள். என்னை மட்டும் கவனிப்பது முக்கியமல்ல, வந்திருந்த விருந்தினர் அனைவரையும் கவனிக்க வேண்டும் என்று சொன்னார்கள். ஸோ இப்படிப்பட்ட சில வேறுபாடான குணங்கள் தான் அவர்களை உயர்ந்த மனிதராக நிலைநிறுத்தியிருக்கிறது. நாம் இன்னும் சொல்லப்போனால் சொல்லிக்கொண்டே போகலாம் அவருடைய சிறப்புகளை. இருந்தாலும் காலத்தின் அறிவை கருதி இத்தோடு உரையை நிறைவு செய்து வாய்ப்பளித்த அனைவருக்கும் நன்றி கூறி விடைபெறுகிறேன். நன்றி, வணக்கம்.
Thank you, sir, for sharing your memories with our founder. And now, I request our Vice Chairman, Thiru K.R. Krishnamurthy, to honor the chief guest with a memento and shawl as a token of our gratitude.
Thank you, sir. And I welcome our correspondent, Thiru K.R. Arunachalam, to honor the special guest with a memento and shawl as a token of our thankfulness.
Thank you, sir. And now, I welcome Dr. S. Shanmugavel, Director, National Engineering College, to give the presidential address.
Very good afternoon. Respected chief guest of today's function, Dr. V. Narayanan, distinguished scientist, Apex grade, Director, Liquid Propulsion Systems Center, Indian Space Research Organization, Valiyamala, Thiruvananthapuram. Respected special guest, Mr. V. Senthil Kumar, Head Antenna and Passive Systems Division, Communication Systems Group, ISRO Satellite Center, Bangalore, and also a distinguished alumnus of our college. Respected Vice Chairman of our college, respected correspondent of our college, respected member managing committee, respected principals of KR group of institutions, deans, heads of departments, dear colleagues, students, and ladies and gentlemen. I'm extremely happy to be part of this celebration. We have all assembled here to gratefully remember a noble soul born 87 years back in Ramasamy near Kovilpatti, and our chairman, founder chairman, K.R. Ayya, had a grand vision of transforming lives through quality education and research with human values. And with that vision in mind, he started 3 educational institutions: National Engineering College, Lakshmi Ammal Polytechnic College, and KR College of Arts and Science, in order to provide quality education and research. And to fulfill the vision of our chairman, founder chairman, all our chairman, vice chairman, correspondent, and all the other members of the managing committee have worked day and night in fulfilling the dreams of our founder chairman. We can all feel proud of having got an opportunity to work along with our chairman, vice chairman, and correspondent to fulfill the vision of our founder chairman of providing quality education and research with human values. That is very important. I had the opportunity to meet our chairman when I joined our college around 10 years back. He greeted me with a scent bottle and a foreign pen, and with so much of humbleness he received me. And afterwards, when I was working with him, he always gives respect to all the staff members. That's what I found. Whether somebody is a professor or the head of the department or an ordinary employee, he gives respect and deals every matter with human value. He understands the difficulty of people, and in fact, his vision was to provide this quality education and research to the people in the village. Normally, people in the village do not get the opportunity that normally the people from the cities get. And they don't score high marks also sometimes. Most of the time we study in Tamil medium and we don't get the high marks. But then our founder chairman insists that we have to give opportunity to the students from villages. Then perhaps we can give other opportunities to others. So in that way, he has transformed the lives of many people from the village areas in and around Kovilpatti and throughout Tamil Nadu. So that is the kind of vision our founder chairman had, and we are extremely happy that our present chairman, vice chairman, and correspondent and other managing committee members are continuing to work very hard and with the same zeal. They encourage us to work in fulfilling the dreams or vision of our founder chairman, and let us feel proud that we are part of this institution and we are contributing towards the betterment of the nation. These institutions are dedicated for the nation, and we are also part of the nation building through our founder chairman, and let us rededicate ourselves for the cause that was cause with which these institutions were started. So with these few words, I once again welcome our chief guest and special guest, and I know Dr. Narayanan and Mr. Senthil Kumar for many years, and they are all dedicated scientists, and we are extremely proud that our friends are contributing in ISRO to the extent that they are part of Chandrayaan 3, and we are now ready to hear from Dr. Narayanan about Indian space research programs, past, present, and future, and let us immensely get benefited out of the experiences of these two gentlemen. And with these few words, I once again thank the organizers for giving me this opportunity. Thank you very much.
Thank you, sir. I call upon Dr. T.S. Arun Samuel, Professor, Department of Electronics and Communication Engineering, to introduce our special guest to the gathering.
Very good afternoon
Very good afternoon to all. I'm really glad to introduce the special guest for the Founders Day event, Dr. V. Senthil Kumar, Scientist G, ISRO Bangalore. Dr. Senthil Kumar received his BE Electronics and Communication Engineering from National Engineering College, Koilpatti, and Masters in Communication Systems from College of Engineering, Gindi, Anna University, Chennai. He received his PhD in the field of Ground Station Antenna Systems from Amrita University. He has been working with Communication Systems Group, UR Rob Research Satellite Center, earlier which is known as ISRO Satellite Center, Bangalore, and involved in the design and development of spacecraft antennas and ground station antennas. Now, presently, he is leading the RF research activities in ISRO as group director. He worked in Antenna Research Group, German Aerospace Center as guest scientist in the year 2002 to 2003 and actively involved smart antenna development projects. He served as a deputy project director for mega trophic projects and responsible for many new RF systems during 2008 to 2012. Mega trophic satellite was jointly developed by ISRO India and CNES France for atmospheric studies. He also served as deputy project director for EMISAT satellite during 2012 to 2019. As deputy project director for Chandrayaan 3, he developed many RF systems for communication with ground station and inter-satellite links and also contributed the success of Chandrayaan 3. He received NRDC award, which means National Research Development Corporation, Government of India award in 1998 for the design of low-cost monopulse tracking antenna system. He received ISRO Team Achievement Award and Team Excellence Award for the following achievements: Megatropic satellite in the year 2013, NAVIC receiver for spacecraft applications in 2018, indigenous development X-band antenna system for ground station in 2019. He has a patent titled Ultra Low Side Lobe Antenna Arrays, and he has recently applied one new patent titled Rotary Joints for High Power Applications. His current research is miniaturization of RF technologies in spacecraft. He published 94 technical papers in national and international journals and conference. We are really happy to have such an eminent personality for our Founders Day. Thank you, sir. Once again, thank you all.
Respected Vice Chairman, Correspondent, our Chief Guest, Dr. Narayanan, Director of one of the prestigious ISRO centers in India, Dr. Shanmugavel sir, my teacher in Anna University, and Kalvithanthai Murugavel, Principal today's NEC, and Ram coordinating for this event, and other two principals of the National Lakshmi Mall Polytechnic and KR Arts and Science College, and many of my teachers who are sitting in the first row. So I wish this particular function to remember the founder of this institution, Sri KR Ramasamy avargal. A few words I'll talk in Tamil. ஒரு காலத்தில் வந்து இந்த ஏரியா வந்து எக்கனாமிக்கலாகவும் ரெண்டாவது பொருளாதாரத்திலையும் அதே நேரத்தில் வந்து கல்வியிலையும் ரொம்ப பின்தங்கிய நிலையில் ஒரு 40 வருஷத்துக்கு முன்னால் இருந்தது. ஸோ நாங்கள்லாம் வந்து கிராமத்தில் இருந்து படித்தவங்க. ஸோ எங்களுக்கெல்லாம் வந்து ஒரு வாய்ப்பு ஏற்படுத்தி கொடுத்த திரு கேஆர் மற்றும் அவர்கள் எல்லாரோட குடும்பத்திற்கும், அதாவது பிஸ்னஸ் பண்ணணும்னா எத்தனையோ வழி இருக்குது, பட் இருந்தால் கூட இந்த ஒரு புனிதமான ஒரு இதை நோக்கத்தை தேர்ந்தெடுத்து இதே மாதிரி ஆயிரக்கணக்கான லட்சக்கணக்கான கிராமத்திலிருந்து வந்த படிக்க கஷ்டப்பட்டவங்களெல்லாம் படிக்க வச்சு ஒரு வாய்ப்பு கொடுத்த திரு கேஆர் மற்றும் அவருடைய எல்லா ஃபேமிலி மெம்பர்ஸுக்கும் இந்த கோவில்பட்டி நகரத்தை சுற்றி இருக்கக்கூடிய எல்லாருடைய கிராமப்புற மாணவர்கள் சார்பாகவும் நாங்கள் வந்து உங்களுடைய வணக்கத்தை தெரிஞ்சுக்கிறோம் சார். அண்டு அவங்க பண்ண இது வந்து மென்மேலும் வளர அதுக்கு வந்து இன்றைக்கி வந்து இருக்கக்கூடிய ஆசிரியர்கள் சப்போர்ட் பண்ணி இந்த எஜுகேஷனல் இன்ஸ்டிடியூஷன்ஸை வந்து ஒன் ஆஃப் த கிரேட்டஸ்ட் இன்ஸ்டிடியூஷனாக மாற்றுறதுக்கு லைக் டாக்டர் சண்முகவேல் சார் ஹவு ஹீ இஸ் ஆக்சுவலி ஒர்க்கிங் ஹார்ட். ஸோ எவ்ரிபடி ஷுட் கோஆப்ரேட் அண்ட் தென் பிரிங் திஸ் இன்ஸ்டிடியூஷன் அஸ் எ ஒன் ஆஃப் த pioneering institution in the country. For that, whoever is supporting the staff members, including the faculty and the supporting staff, everybody, I wish you to continue your good work. And I'll take only few words to allow our respected center director, who was the person behind. There are so many thousands of people worked for the Chandrayaan 3 success, and especially Dr. Narayanan and his team, who has done a excellent job in making the Chandrayaan 3 as a safe landing. So to enable him a more time to inspire the young team of engineers, just I'll take few minutes and then I'll conclude my words. I joined this prestigious college in 1988 and I passed out in 1992. And during our time, the facilities and the staff members, okay, it's only a beginning of the college. So we had a lot of problems in getting the good staff. And I remember that KR sir has arranged some of the faculties from IITs to come. Morning they come and evening they go. Anna University. So in that way, he spent a lot of money and lot of efforts in bringing the good staff during the initial period. Today you have a self-reliance in terms of the getting the good staff members, and they are doing a good job. Only one request is, yes, after completing your basic degree, don't end up with getting one job and settle in your life. I hope after completing my degree, I went to master's degree. There only I met our sir, our Shanmugavel sir. He was something like a role model for all of us. During our days, he was very young and dynamic, and he used to inspire. We had only 8 communication systems MTech degree holders in 1992 to 94. He inspired all of us to come up in the life. So when he called Senthil such and such function is organized, then immediately I told sir, I will be there in the morning, like that. So under his leadership, there are so many professors, so many people are working, and utilize their wisdom, their experiences, and then you come up in life with continuing your education. Don't stop with your BE. Go for your master's degree. If possible, you go for your research, and then you contribute. Don't settle with the job, whatever you are getting after your BTech degree. Don't settle. With that words, I'll leave this forum to Dr. Narayanan to inspire this younger team, young engineers to come up in their life. And really, we know what is the contribution done by his team for soft landing of the Chandrayaan mission. The mission is one of the prestigious mission, not only for ISRO, for the entire country. So in that way, I thank my teaching staff. I don't want to name one by one. If I miss somebody, it will not be good. Starting from Shanmugavel sir to Shanbagavalli madam and Tamil Selvi madam and our Pudiya Segar, Nilakantan, everybody, and Paramasivam sir also. He was part of our initial days we had. So I thank everybody. I wish this organization, this educational institute, to come up to a greater height. For that, whatever possible small help by delivering the guest lectures or providing some kind of practical inputs for encouraging the student, always I'll be there, sir. And especially somebody is working in a field of microwave or antenna, out of the way we will come and support you with that assurance. Thanks very much for giving this opportunity and honoring me in a dais where Dr. Narayanan also sitting. For that I am very thankful for all the management and Shanmugavel sir. Thank you very much. All the best. Thank you.
Thank you so much, sir, for your presence and sharing those words. Next, I am pleased to welcome Professor A. Rajeshwaran, Principal of Lakshmi Mall Polytechnic College, to deliver his valuable words about our chief guest.
Good afternoon to all of you. I feel privileged and honored in introducing our chief guest, Dr. V. Narayanan, on the occasion of our Founders' Day celebration. Dr. V. Narayanan, a distinguished scientist, apex grade, currently director of LPSC, one of the major centers of the ISRO, having its headquarters at Valiyamala in Thiruvananthapuram and a unit in Bangalore. As director, he is providing techno-managerial leadership of LPSC, which is engaged in the development of liquid, semi-cryogenic and cryogenic propulsion stages for launch vehicles, chemical and electric propulsion systems for satellites, control systems for launch vehicles, and transducer development for propulsion system health monitoring. Dr. V. Narayanan joined ISRO in 1984 and functioned in various capacities before becoming the director of the center. As a project director for C-25 cryogenic project of GSLV Mark III, lead the team, successfully developed C-25 cryogenic engine and played vital role in the successful launch of GSLV Mark III vehicle in its maiden attempt, that is first attempt. When India was denied the complex cryogenic propulsion technology for GSLV Mark II vehicle, he has played crucial role in the successful development of cryogenic upper stage and contributed in making it operational for the GSLV Mark II vehicle. During the initial period in ISRO, he also contributed in the solid propulsion system realization for launch vehicle. It was under his leadership that the liquid propulsion roadmap of ISRO for the next 20 years was generated. Under his leadership, the center has delivered 183 liquid propulsion systems and control power plants for various ISRO missions. For the Aditya spacecraft, the center has realized LAM as well as 4 numbers of 10N thrusters and associated components. Towards GSLV Mark III for Chandrayaan 2 and Chandrayaan 3 missions, L110 liquid core stage and C-25 cryogenic stage was delivered for the vehicle. Particularly, the propulsion systems for orbiter, Vikram lander, which include the throttleable thrusters for soft landing, were also developed and delivered for the missions under his guidance. He was the chairman of National Level Failure Analysis Committee, which pinpointed the reason for Chandrayaan 2 hard landing and recommended necessary improvement for Chandrayaan 3 and contributed for the success of Chandrayaan 3. He is currently the chairman of Program Management Council of Space Transportation Systems of ISRO, Mission Readiness Review of PSLV C-52, C-57, and Test Vehicle Demonstration. Actually, before joining ISRO, he has worked with TI Diamond Chain Limited, Chennai, Madras Rubber Factory, Tirthani, Bell, Tiruchi, and Ranipete for 1.5 years. Dr. Narayanan is an alumni of IIT Kharagpur and has completed his MTech with first rank in cryogenic engineering in the year 1989 and PhD in aerospace engineering in the year 2001. He is a recipient of many awards like Silver Medal from IIT Kharagpur for first rank in MTech, Gold Medal from Astronautical Society of India, ASI Award for Rocket and Related Technologies Development, Performance Excellence Award, and Team Excellence Awards of ISRO. He is also awarded honorary degree of Doctor of Science from Satyabama University, Chennai. He has been awarded with the Distinguished Alumnus Award in the year 2018 by IIT Kharagpur and APJ Abdul Kalam Award in 2023. Dr. Narayanan is a fellow of Indian National Academy of Engineering, Institution of Engineers, Indian Cryogenic Council, Aeronautical Society of India, Astronautical Society of India, in members in various national and international professional bodies. So Dr. Narayanan has published large number of technical papers in national as well as international journals. He is at present the National President of Indian Systems of Science and Engineering. We are really proud to have such a distinguished scientist as chief guest today, and we are all eager to listen his special lecture. With this, let me conclude the introduction of chief guest, and I thank everyone for giving me the opportunity. Thank you, one and all.
Thank you so much, sir. To quote the words of Dr. APJ Abdul Kalam, excellence happens not by an accident. It is a process. And our chief guest, who has engineered his path with perseverance and hard work, is the perfect epitome. And I am so proud to welcome our honorable chief guest, Dr. V. Narayanan, Director, Liquid Propulsion System Center, ISRO, Thiruvananthapuram, to give a special lecture on India's space programs, past, present, and future.
I can operate. Very good. பெரும் மதிப்பிற்கும் மரியாதைக்கும் உரிய இந்த விழாவினுடைய பிரசிடென்ட் சண்முகவேல் சார் அவர்களே, திருமதி சின்னம்மாள் ராமசாமி, சேர்மன் KR கன்சோர்சியம் ஆஃப் இன்ஸ்டிடியூஷன் அவர்களே, திருமதி உயர் திரு கிருஷ்ணமூர்த்தி, வைஸ் சேர்மன் ஆஃப் த இன்ஸ்டிடியூஷன்ஸ் அவர்களே, உயர் திரு அருணாச்சலம் கரஸ்பாண்டன்ட் அவர்களே, நிதிஷ்ராம் அவர்களே, நேஷனல் பொறியியல் கல்லூரியினுடைய முதல்வர் காளிதாச முருகவேல் அவர்களே, லக்ஷ்மி அம்மாள் பாலிடெக்னிக் கல்லூரியினுடைய முதல்வர் ராஜேஸ்வரன் அவர்களே, KR ஆர்ட்ஸ் அண்ட் சயின்ஸ் கல்லூரியினுடைய முதல்வர் மதிவாணன் அவர்களே, எங்களோடு ISROயில் பணிபுரியும் உங்களுடைய மாணவர், முன்னாள் மாணவர் செந்தில்குமார் அவர்களே, மற்றும் ஆசிரியர் பெருமக்களே, அன்பார்ந்த மாணவ மாணவிகளே, பெரியோர்களே, தாய்மார்களே, உங்கள் அனைவருக்கும் முதற்கண் எனது பணிவான அன்பு கலந்த வணக்கத்தை தெரிவித்துக் கொள்கின்றேன். இந்த விழா ஃபவுண்டேஷன் டே செலிப்ரேஷன் கல்வி தந்தை திரு கே. ராமசாமி அவர்களை நினைவு கூர்ந்து நடக்கின்ற இந்த விழாவில் நான் பங்கு பெறுவதில் மிகவும் பெருமை அடைகின்றேன், மகிழ்ச்சி அடைகின்றேன். உங்களுடைய கல்லூரி இந்த விழாவிற்கு வந்து இந்த விழாவில் உண்மையிலேயே பங்கு பெறுவதற்கு எனக்கு வாய்ப்பளித்த உயர் திரு எனது அருமை நண்பர் அன்பார்ந்த சண்முகவேல் சார் அவர்களுக்கு மீண்டும் ஒரு முறை எனது நன்றியை தெரிவித்துக் கொள்கின்றேன். நமது கல்வி தந்தை உயர் திரு கே. ராமசாமி சார் அவர்களை பற்றி பேசினால் பேசிக்கொண்டே இருக்கலாம். நமது நாடு 1947 சுதந்திரம் அடைந்த போது உங்களுக்கு எல்லாம் தெரியும், கிட்டத்தட்ட 97% பாப்புலேஷன் வாஸ் பிலோ த பாவர்ட்டி லைன். எந்த ஒரு துறையில் எடுத்தாலும் நாம் பின்தங்கிய நிலையில் இருந்தோம். அந்த நாட்டை இப்போது 76வது ஆண்டு சுதந்திர தினத்தை கொண்டாடுகின்ற இந்த தருணத்தில் மிகவும் ஒரு வளர்ச்சி அடைந்த நாடாக மாற்ற பாடுபட்டது நிறைய பேர் பாடுபட்டிருக்காங்க. அதில் திரு கே. ராமசாமி, உங்களுடைய ஃபவுண்டர் சேர்மன், அவருடைய பங்கு மிகவும் முக்கியமானதாகும். ஒரு நாடு வளர வேண்டுமென்றால் பல துறைகளில் வளர வேண்டும். மிகவும் முக்கியமாக கல்வித்துறையில் வளர வேண்டும். நம்மளுடைய ஃபவுண்டர் சேர்மன் ஒரு சாதாரண எளிய குடும்பத்திலிருந்து படிப்படியாக முன்னேறி இன்று கிட்டத்தட்ட ஒரு 2500 பேர் படிக்கின்ற ஒரு நிறுவனத்தை, என்ஜினியரிங் காலேஜ், பாலிடெக்னிக் காலேஜ், ஆர்ட்ஸ் காலேஜ் அனைத்தையும் உருவாக்கி இருக்கின்றார் என்றால் இது மிகவும் மிகவும் பெருமையான ஒரு செய்தியாகும். அவர் செய்துள்ள அந்த தியாகம் எத்தனையோ பிஸ்னஸ் செய்திருக்கலாம். ஆனால் இந்த மாதிரி இந்த நாடை ஒரு வளர்ச்சியடைந்த நாடாக மாற்றுகின்ற ஒரு பணியில் அவர் செய்திருக்கின்ற இந்த அருமையான ஒரு உன்னதமான ஒரு நோக்கத்தோடு செய்துள்ள இந்த காரியம் நமக்கெல்லாம் மிகவும் பெருமையாக இருக்கின்றது. அன்னாருடைய ஃபவுண்டர்ஸ் டே செலிப்ரேஷனில் உண்மையிலே நான் இங்கு பங்கு வகிப்பதில் மிகவும் பெரும் மகிழ்ச்சி அடைகின்றேன், பேரின்பம் அடைகின்றேன். கிட்டத்தட்ட ஒரு 20,000 மாணவர்களை உருவாக்கி உங்களுடைய கல்லூரி இன்று இந்த நாட்டில் மிகவும் அருமையாக சேவை செய்து கொண்டிருக்கின்றது. நான் எத்தனையோ கல்லூரிகளுக்கு போயிருக்கின்றேன். கிட்டத்தட்ட இப்போ இந்த விழா ஆரம்பித்து கிட்டத்தட்ட 45 நிமிஷம் ஆகுது. எல்லா மாணவர்களும் ஒரு நல்ல ஒரு டிசிப்ளின்ட் மாணவர்களாக இருக்கிறார்கள் என்றால் அந்த பெருமை ஆசிரியர்களுக்கும் மாணவர்களுக்கும் அவருடைய பெற்றோர்களுக்கும் உள்ள பெருமையாகும். இதை பார்க்கின்ற போதே எனக்கு இந்த கல்லூரியை பற்றி நன்றாக தெரியும். நேஷனல் இன்ஜினியரிங் காலேஜ்னா எனக்கு சொந்த ஊர் நாகர்கோயில். அதனால் நேஷனல் இன்ஜினியரிங் காலேஜ்னா இது ஒரு பெரிய அருமையான ஒரு கல்லூரி என்று தெரியும். அந்த கல்லூரியை நிறுவிய உங்களுடைய ஃபவுண்டர் சேர்மன் அவருக்கு ஒரு நன்றி செய்கின்ற விதத்திலே இந்த விழாவை நீங்கள் எடுக்கின்றீர்கள். அதனால் எவ்வளவோ வேலைகள் இருந்தாலும் கண்டிப்பாக சண்முகவேல் சார் என்னை கூப்பிட்டதுனால அதுவும் இந்த முக்கியமான ஒரு ஃபவுண்டர் சேர்மனுக்கு விழா நடக்கின்ற இந்த இடத்தில் வர வேண்டும் என்ற காரணத்தினால் இப்போது உங்களது முன்னால் பேசிக் கொண்டிருக்கின்றேன். Dear friends, for making this country as a developed country in 2047, there are so many people who have contributed, including your founder chairman, and we have grown in multiple directions from 1947. You take agricultural sector, you take health sector, you take road transportation system, you take aircraft, you take defense sector, aerospace sector. I think all the areas we are growing and growing. The growth I can tell you with a single example. When our Honorable Prime Minister Narendra Modi ji took over as the Prime Minister of India, during his first visit to UK, I still remember I was staying in Mahendragiri guest house. It was midnight, around 1 o'clock, he was addressing. And when he went to address the audience, the then UK Prime Minister received him with his family, and his wife was to honor our Prime Minister. She was wearing Indian sari, and when he was addressing, he made lot of things. He told the contributions of Indians across the globe, and he finally made one statement: the way Indians are growing and Indians are contributing. I quote, he made a statement: the days are not far away for a Indian-born UK citizen to become Prime Minister of this country. And he told, I meant UK. And I unquote. Dear friends, today you know, it is history. India has overtaken economically UK, and our own brother is sitting there as the Prime Minister of that country. That shows the growth of this country. And today, from the Indian space program, we have done a lot of contribution to the society, and one of the unique contribution, you all know, on 23rd of last month, we are the first nation to land on the south pole of moon for the first time, and made history and put the tricolor top of all nations. It is a very proud moment for all the Indians across the globe. Now, there are so many people who have contributed for the growth of this country. And one of the great person, great son of the soil who has contributed is Vikram A. Sarabhai. And he is the father of the Indian space program. You know, 1947, when we got the independence, why 1947? I took birth, my date of birth is 1964. I still remember 1969, 1975 time frame. even my village, who is close to Nagarkoil, I think there were really poverty. Lot of people were below poverty line. And this great son of the soil, when we were struggling for food, struggling for infrastructure, there were not much road transport system. And he had a vision to bring advanced space technology for the common man of this country. And that is yielding great result today. And today, my talk is centered around that vision. And because of that vision, what the ISRO has accomplished and what ISRO has contributed to this country. That is the topic on which I am going to talk. In fact, I am going to give you an overview of the Indian space program. Thereby, you will get a feel of how a single person's vision has made space program great and greater heights. Now, you know, for bringing the advanced space technology to the common man, there are 3 systems required. We need satellites, தமிழ்ல சொல்லியாச்சுன்னா செயற்கைக்கோள்கள், ரெண்டாவது அதை அனுப்பதுக்கு உள்ள ஏவு தளங்கள், ஏவு ஊர்திகள், லான்ச் வெஹிக்கிள்னு சொல்லுவோம், ஏவு ஊர்திகள். மூணாவது இந்த சேட்டலைட்டை கொண்டு போட்டாச்சுன்னா அதிலிருந்து வரக்கூடிய டேட்டாஸ் இருக்கு இல்லையா, அது ஃபோட்டோஸ் ஆர் டேட்டாஸ், இதெல்லாம் சாதாரண ஆட்களுக்கு பயன்படுகின்ற முறையில் மாற்றுகின்ற கிரவுண்ட் சிஸ்டம். இந்த 3 இதுவும் வேணும்: லான்ச் வெஹிக்கிள், சேட்டலைட் அண்ட் கிரவுண்ட் சிஸ்டம். All these 3 things we started the development simultaneously. In fact, the space program started in the year 1962 by the formation of INCOSPAR, and we had from that last 6 decades. In my talk, you will understand what are the major contributions you have made. My talk is structured like this. I will give you an overall view of the beginning of the Indian space program, the launch vehicle development and current status, spacecraft development and current status, and what are the applications you have brought out, the prestigious Gaganyaan program, Chandrayaan 3 program, space sector reform, and finally the summary. Now, we are having, as I told, there are few verticals. One is the space infrastructure, that is what is the satellite system, and the launch vehicle system, application system, human spaceflight program, and the capacity building. In addition to that, ISRO also has rolled out, India has rolled out the space sector reform through InSpace and NCL system. We are enabling private sectors and startups to do the space activities. That also I will address. Now, the Indian space program was started in the year 1962, and the first launch vehicle, first rocket took off from Indian soil in the year 1963, November 21st. And it was in the year 1967, November 20th, we had a tiny rocket, our own indigenous rocket of this much height, taking off from Indian soil and going to the space. From 1967 to till today, I have put in summary what are all the accomplishments we have made, and later I will explain the details of each accomplishments. Till today, we have accomplished something around 3,500 sounding rockets, and 6 generations of launch vehicles we have developed. And the first launch vehicle was developed by under the project directorship of none other than Abdul Kalam ji, which was placing a satellite of 40 kg in orbit in the year 1980. From that, we have grown to a greater level. Today, that 40 kg satellite mass has become something around 9,000 kg equivalent in the low Earth orbit. That is the capability of our launch vehicle, LVM-3 vehicle. And we have carried out 91 launch vehicle missions from Sriharikota. And it was in the year 1975, we had the first satellite launch, the Aryapata launch, for which the entire technology came from other countries. We were only doing the assembly integration and a couple of testing activities in URSC, present URSC center, where Mr. Senthil Kumar is working. From that place, we have come a long way. We have realized approximately 125 satellites of different types, and we are serving the nation. And we have also accomplished something around 385, something around 400 satellites. We have launched 400 satellites of foreign countries. We have carried out extensive experiments. Now, this slide shows the 1962, when the space program was started in Tumba. The space program was started in the church, what you are seeing. In fact, if you come to that place, Tumba, near to the church, right side, a small shed, there you can see Abdul Kalam, table, chair, where he was sitting and working. And from that complete beginning, we have come. This shows the first launch of the Nike Apache rocket, which is basically a foreign rocket. 21st November 1963 it was launched, and our indigenous rocket, first rocket, was launched on 20th November 1967, which is only 7 kg mass. From that 7 kg mass, today, in something around 50-55 years, we are building a launch vehicle of 642 tons capability. From 7 kg to 642 tons capability. And this shows the different types of sounding rockets, what we have developed and its capability, and something around 3,500 sounding rockets we have placed in, we have launched. And here you can see there are 6 generations of launch vehicles. The first launch vehicle was in the year 1980, as I told, the SLV-3. And then we moved to the ASLV in the year 1992. From that, we have moved in a different capabilities build up. And we have also currently, last year, we have launched a small satellite launch vehicle capable of placing 500 kg in the low Earth orbit. Now, coming to the first satellite launch vehicle, this is the launch vehicle which was developed under the leadership of Abdul Kalam. And the capability is 40 kg to low Earth orbit. And it was on 18th July 1980. The first successful launch took place, and India joined the elite group of spacefaring nations having the launch capability. And coming to the next launch vehicle called ASLV, the capability is 150 kg, and we have launched 4 satellites, 4 launch vehicles. Initially, we had a lot of setbacks. 2 vehicles had problem. Subsequently, we have successfully launched 2 vehicles. And these 2 vehicles, SLV-3 and ASLV, we consider as experimental vehicles, and we learned a lot of technologies through that vehicles. Then coming to today, we are having 4 operational vehicles. The first one is the Polar Satellite Launch Vehicle. I think you all know, till today, we have launched 57 successful PSLV vehicles. Totally, we have launched 59 vehicles and 57 successful vehicles. And this vehicle has done a lot of accomplishments. I will show a couple of slides. One of the important accomplishments is this vehicle has placed for the first time in the world more than 100 satellites, that is 104 satellites, using in a single launch, and made all the Indians proud. Before that, the Russians had only 37 satellites launched in a single attempt. Then this has accomplished important missions like Chandrayaan-1 mission, Mars orbiter mission, navigation satellites, and so many things. And one of the important experiments, what we have carried out is the space capsule recovery experiment. The PSLV placed the space SRE on January 10th, 2007 in the orbit, and it was rotating the orbit for 12 days. Finally, it was safely brought in the predetermined site. When I say it was brought after 12 days, I want to tell you one thing. Assume when you get down in the bus stop and your eyes are closed and you have to come to the auditorium, I don't know how many of you can really reach safely to the correct spot. I doubt most of us will lose our track. And a product which was in the orbit, after 12 days, it was brought autonomously to the safe place. Coming to the next accomplishment, the PSLV has done 104 satellites in a single go. Next vehicle, we call it the Mark II vehicle, for placing something around 2.5 ton in the geotransfer orbit. This vehicle is a workhorse vehicle which has placed number of navigation and communication satellites in the orbit. For that, we have to develop a lot of technologies, including the cryogenic propulsion. And today, the cryogenic propulsion we use liquid oxygen and liquid hydrogen as the propellant combination. This technology was denied to us, and India ventured into the development. We took 20 years and we successfully developed, and today that is the technology what we are using as the upper stage, and we have accomplished till today totally 15 launches. Coming to the Bahubali rocket, we call it as the Bahubali rocket, the launch vehicle LVM-3, capable of placing 9,000 kg in the low Earth orbit or 4,200 kg in the geotransfer orbit. The lift-off mass is something around 620 to 640 ton. This is totally indigenously developed, realized, and successfully used for placing couple of Indian satellites, Chandrayaan-2 and Chandrayaan-3 mission, and the two important commercial satellites. One of satellites, 72 satellites we have placed last year in the orbit. And we have also carried out an experiment called KR experiment. Using this laid the foundation work for the human spaceflight program. Another important propulsion system using liquid hydrogen and liquid oxygen is developed for that. And in the first attempt itself, this worked successfully, flawlessly, and injected the spacecraft in the required orbit. Till today, we have accomplished 7 launches of this vehicle. All launches were, I am happy to report, it is very successful launches. When we talk about this rocket, I would like to tell a couple of points for the students and the teachers to understand. The speed of Maruti car is something around 100 km per hour. And it uses something around 3.5 gram per second fuel consumption. This rocket, when it is lifting off, it is consuming 4,000 kg per second fuel. And it is lifting off. That means 10 power 6 times of the Maruti car fuel. And against the speed of 100 km per hour, this rocket gives you a speed of 37,000 km per hour to inject the spacecraft in the orbit. And next one launch vehicle we have developed called small satellite launch vehicle, which can be assembled in a shortest time for placing maximum 500 kg satellite in the required orbit. Another important experiment what we have carried out is the reusable technology demonstration experiment, because earlier whatever launch vehicle I have told, it's all called the expendable vehicles, and to reduce the cost per launch, per kg of launch, we have to reuse the system. Towards that, we have carried out lot of experiments. Another important thing is the air-breathing propulsion, wherein, when a rocket lifts off, we are carrying fuel, which is having oxidizer and fuel. Instead of carrying both oxidizer and fuel, if you carry only fuel and take oxygen from the air, that will be the best system. But it is very difficult to consume within the required time frame, within the required condition. We have carried out a couple of experiments and demonstrated that technology. And we have also built huge infrastructures. In fact, if you come to Mahendragiri, which is near to our place, you can see thousands of crores of facilities are built. Like that, in our Sriharikota, thousands of crore facilities are built. Now, as on today, our capability is something around 9,000 kg to low Earth orbit or 4,000 kg to GTO. For improving that capability, we are working on improving the Mark III vehicle. We are developing a 200-ton thrust semi-cryo engine which uses liquid oxygen and kerosene. Kerosene na mannanai. இதை வச்சு பயன்படுத்தக்கூடிய 200-ton engine we are developing, and using that stage and improved version of the cryo stage, we can improve the payload to almost 25%. This shows the cryogenic stage, which is having something around 100 tons of liquid oxygen and kerosene. And what you are seeing is a test facility on the right side, which is built in Mahendragiri. Looks like a simple photograph. This cost something around 900 crore is the facility cost. So this is, last year we have built and commissioned in Mahendragiri. Now, for enhancing the payload capability of our vehicle to almost double, something around 17 ton, already we are working on a system called LOX methane engine, a propulsion system using liquid oxygen and methane. And using that system, using number of engines, we are going to improve the capability from current 9 ton to LEO orbit to something around 17 ton to low Earth orbit. Now, another important thing is you would have seen USA, they are recovering the vehicles. Towards that, we are doing lot of experiments and we are going to recover the stages in future. Coming to the satellite area, we have realized till today 125 satellites of different classes like communication, remote sensing, navigation, scientific and experimental satellites. And when it comes to the capability in terms of resolution of cameras, optical cameras, initially Bhaskara we had 1 kilometer resolution. From that, today our cameras are having a resolution of 0.28 meter. That means an object which is 28 centimeter size can be photographed from the space. And coming to the transponders, also we have improved our capability. Satellite bus, the capabilities are increased from 6 kilowatt to 20 kilowatt. And our first satellite what we launched by our Indian launch vehicle was having 40 kg mass. From that, the URSC satellite center, where our friend is working, we have realized 6,000 kg satellite. Till today, that is the highest capability what we are having. For improving the satellite performance, we are also developing a system called electric propulsion system. Coming to the space application, if I have to talk on the space application, it will take one full day to talk on the space application, what is the benefit it has brought to the common man. But I am not going to venture into that. Couple of applications I will talk. One application, to be frank, last 2-3 days I am sleeping hardly 2 hours only, so I am not so comfortable. Anyhow, doesn't matter. Now coming to the Earth observation, there are lot of applications, starting from water resource management, agriculture. In the agriculture area, what we do is we monitor the wetland, we monitor the crop forecasting. Well in advance, we assess the forecast, we forecast the crop output, which is used by the policy makers for ensuring the availability of food grains for the Indians and to enable food security, and land and ocean monitoring, and forest fire monitoring, forest cover mapping, and potential fishing zone. If you take potential fishing zone as one of the applications, India is having something around 7,500 kilometers seashore area. Now, lot of our brothers are involved in the fishing activity. And even in Kanyakumari district, you can see people will go for deep fishing. Sometimes they cross the border and they get into other countries' side. And sometimes they don't catch any fish and they come back. Now, what we do is, using the satellite picture, we assess the mean sea level temperature. We also understand chlorophyll content in the sea. Thereby, we can understand where we will have fishing zones. And this information is passed to the fishermen of this country. Thereby, we get an annual profit of something around 34,000 crore only through this application. And dear friends, ISRO's budget is only 14,000 crore per year. And through this single application, we are getting a profit of 34,000 crore. And now if you take satellite, SATCOM application, TV broadcasting, telemedicine, teleeducation, search and rescue operation, and so many applications we do. And coming to the Navy application, India, there are so many trains, so many locomotives, so many automobiles. So today we have put a system to track the trains. Today we have put the system, almost 2,500 trains can be tracked on real-time basis. And same automobile tracking. And this is yet another application. Another thing is, when our friends goes inside the sea, they are given apps, and that can give the position as well as the information about where they are standing with the local language itself. And with respect to the safety and security, we are doing great service, monitoring the borders. And disaster warning and management, you all know, 2005 tsunami, how many of our brothers we lost. Today we are having a system to monitor. When the tsunami gets generated inside the ocean itself, we can understand tsunami is going to come and we can inform the people. Same way flood monitoring and all sort of disaster we are helping. And in the remote sensing area we have launched 41 spacecrafts still from 1979. Currently 19 spacecrafts are in orbit doing fantastic job throughout the day. And in the area of communications, we have launched 90 numbers of communication satellites, currently 90 number of satellites in the orbit. You all know, 20 years back to make a phone call from here to Chennai, how you have to go to the telephone booth, book the trunk, and you have to wait. And so much time, after that only you will get the call. And international call means you can understand. But now, from here, anybody can call in 30 seconds, 20 seconds, you can make international calls. So that is the great revolution what is done by the satellite communication. Now coming to the insert applications, television broadcasting is one of the applications. I still remember when I joined ISRO in the year 1984, there was only one Doordarshan. Friday there used to be Voliyum Voliyum. I think 5 songs they used to play. And to see that from Trivandrum I used to rush and see. And today, where we are standing, hundreds of channels, whatever you want, you can see YouTube, so many things. So, lot of work is done in that area. And meteorological area, there was a time we were very poor in predicting the weather and announcing when we will get rainwater. But today, the satellite technology has played a crucial role and the accuracy of predictions are excellent. And navigation, as I told, almost 2,500 trains are tracked and locomotives are being tracked, and the boats inside the oceans are getting tracked. And of course, teleeducation and telecommunication is yet another important field in which we have contributed. Now coming to the scientific missions, we had the first successful scientific mission, the Chandrayaan-1 in the year 2008. October 22, 2008 we launched, and we reached to 29th August 2009. And through that mission, we had lot of achievements. 2 major achievements are, India is the first country which found water molecules on the moon surface and made all Indians proud at that time frame. And we also placed our flag, Indian flag, on the moon surface through the Moon Impact Probe. Next important mission is the Mars Orbiter mission. The red planet is at a distance of something around 68 crore kilometers we have to travel to reach the red planet. We accomplished this mission in the first attempt. We started our journey in November 2013 and we successfully accomplished on 24th September 2014. And dear friends, I want to remind all of you, India is the first country which successfully accomplished the Mars Orbiter mission in the first attempt. I think you all can be proud of that achievement. Not only that, for reaching there, you please understand, we have to go 68 crore kilometers. I think all the students, trigonometry. If 0.01 degree, there is a error. You calculate when you travel where you will reach. We cannot reach the moon's in Mars orbit. And such a precision, it has to be guided and it is taken and we have achieved. Not only that, our Honorable Prime Minister used to tell the total expenditure what we have made. If you calculate per kilometer cost, the cost is lower than auto fare. So that is the low cost mission which India accomplished and made all the Indians proud and all the foreign countries to look at on us. Next important mission is the Chandrayaan-2 mission. This mission had multiple roles. 2019 we did this mission. Number one, GSLV Mark III vehicle. The design capability was 4,000 kg. Before 2019, we had demonstrated hardly 3,400 to 3,600 kg. So we had to demonstrate a capability of above 4,000 kg. That was one of the objectives of Chandrayaan-2, LVM-3 M2 Chandrayaan-3 mission. That was one of the objectives. Second objective is the Chandrayaan-2 had 3 systems. There was an orbiter which has to be taken to moon and it has to rotate around moon. Second objective. Third thing is there was a lander and rover system, and using the lander and rover we have to soft land on the moon. Now, when we did this mission, we demonstrated the performance of the satellite launch vehicle. Successfully we accomplished. Then we also took the entire Chandrayaan-2 to the moon's orbit. Exactly, it traveled close to 4 lakh kilometers. It was captured. And the orbiter and lander was separated successfully. And orbiter is designed for 1 year lifetime. And by our innovative mission management system, we ensured a life of 7 years. Even till today the orbiter is successfully working in the moon surface. And it is having number of important payloads. One of the payload is called OHRC camera, on-orbit high-resolution camera. And that can take photograph when the object is less than 30 centimeter. This is the best camera ever developed for moon program in the world. And the camera is even today successfully working. And we have taken the photograph of the entire, mapped the photograph of the entire moon surface. This was accomplished. Now, coming to the next objective, we plan to soft land on the moon. And that soft landing, this is the profile. You can see the object was rotating. The lander rover system was rotating with a speed of something around 6,000 kilometers per hour. And the speed has to be brought to near zero. And we have to soft land. And initial portion, as shown in the graph, it was going well. Beyond 2.1 kilometer, we lost the signal. And finally, the Chandrayaan-2 had a hard landing in the near to the designated site, but it was a hard landing because of high velocity. That means out of the lot of objectives, only the soft landing and rover coming out objective could not be met. Immediately on September 11, 2019, a national level failure analysis, or rather expert committee, was constituted with 9 members to go through the entire data. This satellite had something around 28 or 29 systems. And we have to study the performance of all the systems and understand, pinpoint the reason for Chandrayaan-2 hard landing against the soft landing. Also, we have to recommend the necessary improvements required for a successful Chandrayaan-3 mission. I am very happy and proud to announce that as per the government requirement, a 9-member committee in which I was appointed as the National Committee Chairperson, and this committee worked almost 24/7. 28 days, I will say, most of the team members' average sleep was 3 to 4 hours only. And with that dedicated effort, we studied the entire data and submitted something around 700 to 800 page document, including lot of recommendations for the Chandrayaan-3. And the recommendations includes, the object is rotating at a speed of 6,077 kilometers per hour. From that, it has to be brought to near rest. Something around, I think the software engineers or computer science students can understand, 1.5 lakhs software line is code is sitting in the system. And we have to understand, we have to strengthen the software. This was one of the recommendations. Second thing is it has to move in the required path. And the optimal path has to be assured through the proper navigation guidance control system. This is another recommendation. Then for landing, we are accounting some propellant. We wanted to improve the margin of the propellant. This is yet another recommendation. Then when it comes and soft land, it is, you would have seen like a 4 stools, it is coming and sitting. And that lander leg, we wanted to improve the robustness, capability. Even if it comes with a little more velocity, it should improve. Another thing is, for Chandrayaan 2, we had given a corridor for landing 0.5 kilometer by 0.5 kilometer. Now using the Chandrayaan 2 orbiter, which is having the high resolution camera, we have mapped the moon surface and we defined a corridor of 4 kilometer by 2.4 kilometer. Thereby, even with the dispersion, we can land comfortably. We improved the power capability, power generation capability of the Chandrayaan 3. We also recommended to improve the propellant margin. Thereby, lot of recommendations were given and everything was implemented. Finally, we realized the beautiful satellite, the Chandrayaan 3. The Chandrayaan 3, again it is a 3-in-1 satellite, which had a propulsion module, which has a lander system and a rover system, as you are seeing. And from the Earth, the first job is to take Chandrayaan 3 to the Earth's orbit. To do that, we had to give a velocity of 37,000 kilometers per hour. That is the work done by our beautiful and the Bahubali LVM-3 M4 rocket. You can see the performance we have given there. This rocket is supposed to inject the Chandrayaan 3 in a orbit of Earth is there, 170 kilometer by 36,500 kilometer. And 36,500, the dispersion permissible is plus minus 500 kilometers. Against that, you can see the data, only 9 kilometers was the dispersion. Such a precision was never achieved by any launch vehicle community in the world. And with such a precision, we injected the satellite in the required orbit. Anyhow, the video clipping will come at the end, otherwise it will disturb the presentation. Then, when it comes to the Chandrayaan 3, it had multiple systems. One of the proud DPD is sitting here. And his communication systems, and propulsion systems, inertial system, power system, the camera systems, then payloads. It has so many systems. As an integrated thing, it has to work. And the mass is how beautifully it was accomplished. And it came in the designated path in 19 minutes. The speed was reduced from 6,077 kilometers per hour to near zero. And we successfully landed and made history, made this country proud. In a lighter vein, we used to say, who discovered cyber zero? Any answer? We Indians invented zero. We used to say, we had a credit of discovering zero. And today, 3 parameters, altitude, horizontal velocity and vertical velocity, making all the 3 to near zero, and we have made history. And it is a very, very great achievement. Probably you may be knowing the so-called developed countries were trying to accomplish this before us, but then you know what was the end result. And you can understand the team of engineers who are working, the type of determination, dedication, tension on the day of landing. But then, it was a well, meticulous way this was accomplished. For you to understand the precision at which it was landed, I will give 2 numbers. From that speed to optimally move and land, we have to basically break the velocity. we had loaded 1013 kg propellant. And with modeling and simulation, thousands of modeling and simulation was carried out, and the previous day of landing, we declared, rather I am party to that decision, my team was involved precisely along with URSC team, we declared 943.5 kg of propellant will be consumed. You know what was the propellant consumed? It was 943.4 kg, only 100 gram difference. I don't think any country in the history of space program has got this type of accurate estimate and accurate accomplishment. Really, the Indians have not done just like that. Indians have done with great level of maturity, great level of understanding, great level of dedication, and put the national flag above all the countries. Now, having landed, we had to monitor the entire health. We took almost 3 hours to understand the health of the system. Then there is a beautiful baby called rover, Pragyan rover, 26 kg rover was inside. And without understanding, simply if you open the door, ramp, if you open, if it is getting exposed to low temperature, sometimes it will not work. So we have to understand the health of entire system. And finally, the rover was brought out. Before bringing out, it had a solar panel which was deployed, and electricity was produced from the sun rays. And finally, it was history. After 3.5 hours, the rover, the baby came out from like a mother's womb. It came out successfully and rolled on the moon surface. And India is the first country which has done the rovering action in the South Pole for the first time. And today, to our credit, it has moved 100 meters here and there. And we had another important achievements. Probably a lot of you people may not be knowing. We planned only this much experiment as per approved project. Finally, we understood, having done the accurate calculation of the propellant, we thought we will do some more experiments. You know, this is not the end of this mission. We may have to go for future missions like sample return, human space, all those things may be required. For sample return mission, what is required is after landing, you have to again take it back. So we decided on 2nd of this month, we went back from Sriharikota after the Aditya L1 launch. Throughout night, we took flight 10 o'clock from Chennai, landed in Bangalore. Throughout night, we are working. Lot of simulations, lot of calculations, because, you know, successfully it is landed. Now, if you try to lift, it should not collapse. We should not break the system. Then that will really bring bad name. And we did lot of simulation studies. Finally, we authorized the engine to fire for 300 milliseconds to understand. After operating that, we authorized to fire the engine system for 1 second, and we lifted the craft by more than 40 centimeter and moved to another place 40 centimeter, and we re-landed. This is a great experiment which was done with the same cost of the approved project. That means for the approved project is accomplished with half of the original cost. And this is going to really yield good result for the coming generation to carry out future moon exploration or Mars exploration activities. And coming to the payloads, we had 6 beautiful payloads in this mission. One is called the Ramba payload, meant for finding the plasma density. Dear friends, India is the first country and only country which has found the plasma density there. We have discovered 5 to 30 million electrons per meter cube, and we have declared in our site. And we wanted to understand the Earth thermal property. There was a beautiful sensor called Chandraya's Surface Thermoelectric Experimental Sensor, which is having a protrusion rod having 10 thermocouples, and the payload was pierced inside the surface, and we have measured the temperature on the surface. It was 60 degrees centigrade. In 10 centimeter down, the temperature was minus 10 degrees centigrade. This is a great discovery on the moon surface. Coming to the next, Like earthquake, we wanted to understand the seismic activity on the moon surface. And you can see the beautiful graph. There are seismic activities, some places, not all places, there are places seismic activities are there, for which we use 6 mumps vibrometers, vibration sensors, and that has yielded beautiful result. Another important experiment is to understand the minerals and chemicals on the surface. To our credit, we have discovered 8 minerals on the moon surface, like manganese, iron, titanium, aluminum, chromium, sulfur, calcium. This is not only we have discovered, we have also shared the data with international community. Today, the entire international community is looking, the scientific community. There was a time after independence, we were looking the science data from abroad. Today, we are happy to report and declare that through this Chandrayaan-3 mission, we have discovered and sharing huge wealth of data for the scientific community of not only this country, entire globe. And all the spacefaring nations, including the developed countries, are acknowledging our contribution in a big way. Yesterday night, I had a meeting with 600 excellent doctors from across the globe. The way they received the data and the way appreciated is phenomenal. And in fact, I told India is going to become a developed country 2047. They came and told, sir, don't tell this, India has become a developed country. That is the statement they made. Now, coming to the achievement, summary achievement of Chandrayaan-3 mission. We have successfully soft landed on the moon, the first country to land on the south pole of the moon, discovered various aspects of the moon. Important achievement is 143 Indians across the globe is integrated by this mission. Irrespective of the region, state, caste, community, region, we have integrated the Indians across the globe. And it has generated scientific timber across the country. And when this was successfully landing, as a person who has spent sleepless night along with one of the deputy project directors, I was thinking that this is the stepping stone for India to become a developed country in 2047. I don't have any doubt that India will become a developed country, and this is a stepping stone. And dear friends, dear engineering college and arts college students, you are having a great role to play to make this country as a developed country in the coming years. For that, the teachers has to make a strong foundation. Now coming to next important program, our Gaganyaan program, which is meant for taking Indians by Indian launch vehicle to low Earth orbit. Actually, taking the Indians and putting in the space is very easy. Anybody can be taken and put. But keeping them safe and bringing them back safe is the difficult job. So we are working towards that program. And so much work has been done to take our own brothers or sisters to space. And couple of years we are going to do the accomplishment. Next month we are planning a very, very important experiment towards this. Now, when Chandrayaan-3 activity was going on, we have realized a beautiful satellite called Aditya L1 satellite. And India is the 4th country in the world to realize a satellite for studying exclusively moon. It is a 1480 kg satellite which was lifted off successfully by using our PSLV C-57 rocket on 2nd of this month. And PSLV injected in a beautiful orbit of 235 kilometer by 19,520 kilometer elliptical orbit. From that, we have to take it to travel to 1.5 million, 15 lakh kilometer, and we have to place the satellite in the Lagrangian L1 stable point where the satellite has to revolve and continuously face the sun. We are having 7 excellent payloads. Right now, we have moved the satellite from 19,520 kilometer to yesterday early morning. Yesterday, early morning, 2:30, we moved to 1,22,000 kilometers successfully. And on 19th, we are 19th of this month, that means Tuesday, early morning, we are going to give command to move the Aditya L1 to move towards sun. Then it takes something around more than 100 days. January 1st week, it will go to the required orbit and it will get captured. And I am 100% confident it will be a successful, yet another successful and proud mission. And India is going to be the 4th country to have that capability. Today, dear friends, the government of India has rolled out the space sector reform. Right now, we are having something around 55 spacecraft in the orbit, doing the job of remote sensing, earth observation, communication, navigation, and strategic application. I would like to tell one data. Our counterparts, Chinese, last year alone, they have launched 45 satellites to monitor the border. Then you can understand the type of capability what we have to build to protect ourselves. They are having more than hundreds of satellites only for strategic applications. So we need huge number of satellites for communication. I don't know how many of the communication students are aware. Even though we have done revolution in the country in the communication area, even today, 30,000 villages are not having telephone connection. It is our responsibility to ensure telephone connection, mobile connectivity to the entire country. It is our responsibility to ensure safety and security of this nation. We used to make a statement, space is for defense, defense is for space. Yes, if you don't have a safety and security after when we celebrate 100 years of independence, what is that we are talking about a developed nation? So we need to have number of satellites for multiple purpose, starting from disaster management, meteorology purpose, whatnot. You take any purpose. Today we have to depend on satellite data. I am telling you, after 10 years, today you may not be knowing if you are having land whether somebody is grabbing or not. They activities. And through our system called InSpace, which is responsible for authorizing and promoting space activities through space startups. And we are having a commercial wing called NSIL. We are, as I told, something around 342 or 350 foreign satellites we have launched. So to enable the commercial capability, before the Chandrayaan 3, we launched 2 Mark 3 vehicles. Because of the Russia-Ukraine geopolitical situation, we got the opportunity to launch 2 commercial launches for OneWeb. We have placed 72 satellites successfully in the shortest time frame in the orbit, and we are in the front in the commercial area also. To enable this activity is rolled out, and some of you will get great opportunity to start your own space companies. And yes, we have done lot of things. Today our capability is 9,000. When Abdul Kalam did the launch, we had the capability to place 40 kg satellite to orbit. Today our capability is 9,000 kg. From that we have got approved project close to 17,000 kg. And we are working to enhance this capability multiple times so that future we will be world leaders in the space program. And we are building the capability to have multiple programs like docking experiment, and of course human space flight program, and in situ propellant utilization in other planets. And you know, today Americans are working on finding diamonds inside the ocean through the space systems. Like that, lot of applications are there. We are working in multiple programs. I am sure, like your colleague, some of you will become party to this activity. Whether you are a party for space activity or not, I have a humble suggestion and request to all of you. I am sure India will become a developed country in 2047. I want your contribution one way or other through any source, one way or other, for making this country as a developed country. Dear friends, please imagine the vision of a single person called Vikram Sarabhai has done marvelous thing and taken forward by generations of leaders, and today Indian space program is really on the top, and we have made multiple places first rank, and we have made India proud. And like that, your founder chairman also has done his contribution through the education system. I want each and every one of you not to become a materialistic personality, to become a visionary leader and contribute for the growth of this country. On this occasion, on behalf of the ISRO community, let me thank and wish the entire education system in this campus to go greater and greater heights. And this institute should become much better than IIT standard. For that, management has to work, teachers have to work, students have to cooperate. I don't have any doubt, once there is a discipline, this will happen. Let me come back to the last point. I am extremely happy to be with you on this wonderful day. Let me thank Professor Sanmugavelu and the entire organizing team to give me this great opportunity to stand in front of you on this excellent Foundation Day and share a couple of my thoughts on behalf of the Indian Space Program. Thank you. Jai Hind.
Thank you, sir, for those words. Today,
Now, I don't know, sir, how much time you have. If you have time, there is a 7-minute video. Video is there. If you want, we can. No, if you all agree, if you have time, I am not sure. There is because I could not show the video clipping because I thought I will operate the system. There is a video of Chandrayaan 3 landing for 7 minutes. Probably you can enjoy that video. Hope you all will enjoy the video. So thank you once again. Thank you. Jai Hind.
To Chandrayaan 2, propulsion module of Chandrayaan 3. Strategy of Chandrayaan 3, from spacecraft injection till lunar orbit acquisition, is similar to Chandrayaan 2. Propulsion module of Chandrayaan 3 will carry lander module up to approximately 100 by 100 kilometers lunar polar orbit. Subsequently, lander module will get separated from propulsion module at 6 days before landing. The new onboard functional verification strategy is adopted to assess the health and functional characterization of landing sensors and propulsion system during these 6 days. Day. Powered descent starts at appropriate time on day 7. Before the start of powered descent phase, orbit determination activity will be continuously carried out by utilizing JPL, ESA, ISRO ground stations and orbit models. The accurate orbit determination estimation is very essential to determine precise initial conditions of lander-powered descent, which is one of the critical requirements to achieve safe and soft landing. Powered descent phase consists of 4 subphases, namely rough braking phase (RB), attitude hold phase (AH), fine braking phase (FB), terminal descent phase (TD), which is similar like Chandrayaan-2 except for phase durations and target milestones. All sensor electronics will be in on condition prior to start of powered descent phase. However, absolute sensors will be operated at the respective phases as per the powered descent plan. The filter will be updated by absolute sensors and the filter which in turn will be updating the inertial and local navigation at discrete intervals as per the descent plan. Inertial sensor will always be in closed loop with guidance and control throughout the descent phase. Rough braking phase will start from a nominal altitude of approximately 30 kilometers with orbital velocity of approximately 1.68 km per second. A second order polynomial closed loop guidance law with pure inertial navigation is planned for this phase. No absolute sensor will be taken in loop during this phase. All 4 liquid engines will be operated at higher throttling level to reduce the horizontal velocity. Maximum downrange will be covered during this phase. Total duration of this phase will be approximately 690 seconds with a downrange of 713.5 kilometers. At the end of this phase, lander will be at an altitude of 7.4 kilometers and its attitude will have 50-degree pitch angle with respect to vertical. The expected vertical velocity and horizontal velocity at the end of rough braking is 61 meter per second and 358 meter per second respectively. At this moment, lander will be approximately 32 kilometers away from targeted landing site. Also, a constant check on vertical velocity will start from an altitude of 18 km onwards. In case of any dispersion beyond design limits, emergency landing will be triggered, which will invoke salvage guidance algorithm. Rough braking phase is followed by attitude hold phase, which is planned for a nominal duration of 10 seconds. Guidance law in this phase runs in open loop with pure inertial navigation to decouple attitude control from guidance and maintains a constant 50-degree pitch angle throughout the phase for both altimeters to look at neither direction. Both altimeters, Kara and Lhasa, will be operated in this phase and altitude data will be taken into navigation filter. These sensors update will be enabled to the filter from 10 km altitude. At the end of this phase, navigation filter will update inertial navigation with altitude information. Altitude of lander is expected to be approximately 6.88 kilometers. Lander module will be 28.5 kilometers away from planned landing site. Guidance bound check will be done to see if given landing site is reachable or not. In case if it is reachable, lander will be targeted to the designated landing site. If not reachable, then real-time retargeting will be invoked to reach neighboring landing site. if the guidance states are much beyond the real-time retargeting limits. Emergency landing will be invoked. During this process, if there is a valid altimeter update, then the lander will be targeted to an altitude of 800 meters. And in case there is no valid altimeter update from both the sensors, the targeted altitude will be increased to 1300 meter to cater for inertial navigation dispersion. A third order polynomial closed loop guidance law is planned for this phase, with LIRAP propagated inertial navigation. In case if there was no valid altimeter update in the previous phase, then one more update from filter LASA altimeter data will be planned at 35 seconds from start of this phase. LDV will provide information about 3-axis velocity with respect to moon surface from an altitude of 2.5 kilometers and below. Navigation filter will run in background and will get update from LDV. Inertial velocity will get corrected by update from filter to navigation at time to go of 39 seconds. At the end of this phase, lander module will be vertically above targeted landing site at an altitude of 800 or 1300 meter from local surface with zero velocities. Emergency landing logic will continuously monitor vertical velocity and salvage guidance will be invoked if dispersions goes beyond limit. Inertial navigation will be terminated and local navigation will be initiated to perform relative navigation with respect to local surface. Terminal descent will start from an altitude of 800 meters or 1300 meters. If all the requirements are met, two opposite liquid engines, 1 and 3, will be shut off at the start of this phase. Lander module will hover above landing site for 12 seconds using PV guidance. LDV and CARA will be taken in loop to update height and velocity information to navigation filter. LASA and LHVC will operate in background as a redundant sensor to CARA and LDV. At the end of hovering, navigation filter will update navigation. Subsequently, lander module will descend vertically up to 150 meter local altitude using third order polynomial guidance law. During this phase, the local navigation states will be updated at discrete intervals by filter. At 150 meter, lander module will again hover for 22 seconds using PV guidance. CARA and LDV will be taken in loop to update height and velocity information to navigation filter. During this time, hazard detection camera LHDAC operation will be carried out to find safest location within 150 meter downrange for landing. The first preference will be given to the location just below lander, if it is safe. In this case, lander module will vertically descend to 10 meter above landing site. In case LHDAC finds different safe location, lander module will be retargeted above new landing site at an altitude of 60 meters with zero velocity. In retargeting phase, no absolute sensor update will be taken into the loop. From 60 meter, lander module will vertically descend to 10 meter altitude using third order polynomial guidance. During this phase, the local navigation states will be updated at discrete intervals by filter. LDV will stop updating below 30 meter and CARA will stop updating below 10 meter altitude. Filter will not be updating using any absolute sensor below 10 meters altitude. Module will approach the lunar surface with constant velocity of 1 meter per second. At touchdown, contacts with sensors in lander leg will sense the touchdown and based on it, NGC will command to shut off all
Thank you, sir, for sharing this informative video. I feel privileged and honored to stand here in front of you all and acknowledge the achievements of our brilliant and talented students who have made their parents proud by receiving Kalvithanthai Thiru Ramasamy Memorial Scholarships. I call upon Dr. K. Kalidasa Murugavel, Principal, National Engineering College, to present the name list of the achieved students. And I request our chief guest to do the honors.
கல்வித்தந்தை உயர்திரு கே ராமசாமி நினைவு தகுதிசார் உதவி தொகை திட்டத்தின் கீழ் +2 பாடத்திட்டத்தின் கீழ் 190 கட் ஆஃப் மார்க்குக்கு மேல் அதிகமாகவும் நிர்வாகத்தினர் அங்கீகரிக்கப்பட்ட போட்டிகள் வெற்றி பெற்ற மாணவர்களாகவும் விளையாட்டுத் துறையில் சாதனை படைத்த மாணவர்கள் அனைவருக்கும் இதில் அனைவர்களையும் நேர்முக தேர்வு மூலம் தேர்வு செய்யப்பட்டு தகுதி வாய்ந்த மாணவர்களுக்கு நமது தேசிய நேஷனல் பொறியியல் கல்லூரியில் பொறியியல் பட்டங்களை தொடர உதவித்தொகை ஒவ்வொரு ஆண்டும் வழங்கவிருக்கிறது. இந்த கல்வியாண்டில் 23-24 கல்வியாண்டில் கீழ்கண்ட மாணவர்கள் நேர்முக தேர்வின் மூலம் ஸ்னேகா முழு கல்லூரி கட்டணம் மற்றும் ஹாஸ்டல் கட்டணம், ஸ்னேகா முழு கல்லூரி கட்டணம் மற்றும் ஹாஸ்டல் கட்டணம். தென் லக்ஷ்மி கங்கா முழு கல்லூரி கட்டணம். ரிஃபானா நஸ்ரீன் முழு கல்லூரி கட்டணம். ஜாஃபர் ஜரீன் டியூஷன் ஃபீஸ், கல்லூரிக்கான டியூஷன் ஃபீஸ் உதவி. ஆசர் நமீரா டியூஷன் ஃபீஸ் உதவித்தொகை. பிரேமா சுந்தரி டியூஷன் ஃபீஸ். ஜனனி முழு கல்லூரி கட்டணம். ஜனனி கல்லூரி கல்வி கட்டணம். சண்முகப்பிரியன் டேலண்ட் ஸ்காலர்ஷிப். நன்றி.
Thank you, sirs. I call upon Dr. S. Madhivannan, Principal, KR College of Arts and Science, to present the name list of the achieved students. And I request a special guest to do the honors.
நல்லாரை காண்பதும் நன்றே, நலமிக்க நல்லார் சொல் கேட்பதும் நன்றே, நல்லார் குணங்கள் உரைப்பதும் நன்றே, அவரோடு இணங்கி இருப்பதும் நன்றே எனும் அவ்வை மூதாட்டியின் வாக்கிற்கிணங்க நல்ல உள்ளம் கொண்டு வாழ்ந்து இன்றும் நம்முள் வியாபித்துக் கொண்டிருக்கும் கல்வி தந்த தந்தை உயர் திரு கே ராமசாமி ஐயா அவர்களின் அருளாசியுடன் விளையாட்டுத் துறையில் பல்வேறு பிரிவுகளில் சாதனைகள் படைக்க நம் KR கல்லூரி மாணவர்களை ஊக்குவிக்கும் விதமாக ஆண்டுதோறும் சிறந்த விளையாட்டுத்துறை மாணவர்களுக்கு கல்வி கட்டண சலுகைகளும் விளையாட்டு உபகரணங்களும் கல்லூரி நிர்வாகம் சார்பாக வழங்கப்படுகின்றன. அந்த வகையில் 2023-24 கல்வியாண்டில் மாநில அளவில், மாவட்ட அளவில், பல்கலைக்கழக அளவில் ஹாக்கி, கைப்பந்து, தடகள போட்டி எனும் பல்வேறு போட்டிகளில் பல சாதனைகளை புரிந்து கொண்டு நம் கல்லூரியின் புகழினை நிலைபெற்று வளரச் செய்யும் மாணவ மாணவிகளின் பெயர் பட்டியல். முதலாவதாக கே கலாநிதி, ஃபர்ஸ்ட் இயர் BSc பயோகெமிஸ்ட்ரி for hockey. MK Viswa, first year biochemistry for hockey. B Madhumita, first year BSc biochemistry for handball. Elil Arasan, first year BA English literature for hockey. E Isakimuthu, first year BA English for hockey. Mr. A. Pravin, first year BA English for hockey. Mr. Team Manishankar, first year BA English for hockey. T. Manishankar. K. Srinivasan, first year BCom Professional Accounting for hockey. S. Aswini, first year BCom Professional Accounting for athletics and handball. K. Rubika, first year BCom for handball. B. Logeshwari, first year BCom PA for handball. K. Bharat, first year BSc Computer Science for hockey. R. Renuka, first year BSc Computer Science for athletics and handball. M. Aswa, first year BSc Computer Science for handball.
Thank you, sir. I invite Professor A. Rajeshwaran, Principal of Lakshmimal Polytechnic College, to read names of achieved students. And I request our special guest to do the honors.
For Lakshmimal Polytechnic College, Kalvithanthai Thiru K. Ramasamy's Memorial Sports Scholarship for the year 23-24. For hockey, Mr. Ayyambarumal from first year ECE, he will receive 50% concession in the tuition fees.
Thank you, sir. Next, I am bound to welcome Dr. S. Madhivannan, Principal of KR College of Arts and Science, to deliver the vote of thanks.
Good evening to all, gathered physically and virtually to celebrate the birth anniversary of our founder chairman, Kalvithanthai Thiru K. Ramasamy Ayya. Let me propose the vote of thanks by quoting the words of Bharat Ratna Padma Vibhushan Dr. APJ Abdul Kalam. An ignited mind is the most powerful weapon on the earth, above the earth and under the earth. And this is God through education. As per his words and the vision of our founder chairman to educate the students in our community, our KR educational institutions are deliberately working under the chairmanship of our Madam Tirumadi Channamal Ramasamy. Thank you, Madam, for your elite guidance. Confidence and hard work is the best medicine to kill the disease called failure. As per Dr. APJ Abdul Kalam, to combat failure and to be always success, we are fortunate to be under the distinguished leadership of our Vice Chairman Thiru K.R. Krishnamurthy and correspondent Thiru K.R. Arunachalam. Thank you, sirs, for your distinct leadership. I profoundly express my gratitude to Mr. A. Nitish Ram and all management committee members for their coordinated support. If you want to shine like a sun, first burn like a sun. Today's chief guest, Dr. V. Narayanan, Director, Liquid Propulsion System Center, Indian Space Research Organization, really inspired and guided us how to be efficient and productive in the era of technology, and we are really proud to have you, sir, as the achievements of ISRO will surely draw the young minds towards the research and development. Thank you, sir, for sharing your valuable time with us. Success of any institution can be measured by the contribution made by alumni to the national growth. I am sure that Mr. V. Senthil Kumar, NEC alumnus 1992 batch, has contributed towards a nation's pride by putting his sincere efforts in ISRO as head antenna and passive system division. We thank you, sir, for your elite speech and spending your time in the Founders Day celebration. Train your mind to be calm in every situation. As per Dr. ABJ's words, to compete and excel, we are having our dynamic director, Dr. S. Shanmugavel, for guiding us. Thank you, sir. Making 100 friends is not a miracle. The miracle is to make a single friend to stand beside you in hard times. To do these words, I thank Dr. K. Kalvithanthai Murugavel, Principal National Engineering College, and Professor A. Rajeswaran, Principal Lakshmi Ammal Polytechnic College, for their peer support and help rendered by them to make today's event a grand success. It is my pleasure to thank all the guests and invitees for their able support and time. I owe my sincere thanks to the parents for the everlasting belief and the enduring support rendered by the faculty and staff members of National Engineering College, Lakshmi Ammal Polytechnic College, and KR College of Arts and Science. I express my heartfelt gratitude to the alumni of KR educational institutions, as they are the real flagship bearers and the pride of our institutions. Finally, I register my sincere thanks to the press and media persons who are the unsung heroes in popularizing the news and information. I conclude my vote of thanks by earmarking a Thirukural, நயனோடு நன்றி புரிந்த பயனுடையார் பண்பு பாராட்டும் உலகு, நீதியையும் நன்மையையும் விரும்பி பிறருக்கு பயன்பட வாழும் பெரியோரின் நல்பண்பை உலகத்தார் போற்றி கொண்டாடுவர். Yes, the world applauds the character of those whose usefulness result from their equity and charity. Let us also try to follow the words of the Tamil Pudavar Thiruvalluvar to be good and grateful in the advanced technological society. Thank you for the opportunity. Thank you. Have a great day.
Thank you, sir. I now request the gathering to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलति तरंगा तब शुभ नामे जाहे तब शुभ आशीष माहे गाहे तब जय गाता जनगण मंगल जय 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 हे.
I request the audience to stand up and show respect while the dignitaries process outside the auditorium.